Okay, today we're going to review a little bit of what we've been doing, identifying the parts by looking at a graph, looking at a table, and looking at an equation. And then I want to do 3 real-world problems where you're reading a graph and finding all of these parts and interpreting what they mean in real context, okay? So I'm not going to do every one of these problems, the graphs and what we've been doing, but I want to do, just kind of highlight some things to remind you. All right, so looking at the graph, we know that this is a oops. Okay, we know that this is a quadratic, this is a linear, this is an exponential, and this is an exponential, right? All right, for maximum and minimum, we know that on a linear, there's none. On a quadratic, this is the minimum, so maximum's none. And our minimum is this point, 4, -3, okay? And we have our y-intercept and then our 2 x-intercepts, okay? Here, your y-intercept is 0, 0, the origin, and it's also your x-intercept. Okay, it's crossing both axes. All right, for your exponential, this one is a minimum. This one is a maximum. All right, so this one has no minimum and no maximum. All right, and here the minimum is approaching -1. This one is approaching 1, 2, 3, 4, approaching 4. All right, and then you would do x-intercept, y-intercept, x-intercept, y-intercept. Both of them's origin. Okay. All right. Next, looking at tables, I want to do a couple of them where you have to extend the table. Okay, so let's look at this first one. Remember, linear is a constant first difference, right? Quadratic is the second difference. And absolute value is going to be a plus minus constant. Then exponential, you're multiplying. Okay? All right, so this, you look, 18 to 24, we're adding 6. Adding 6, 30 to 36, we added 6, we added 6. Okay, so I know it's going to be linear, so there's no minimum maximum. So I need my y-intercept, which means my x is 0, and my x-intercept where my y is 0. Well, I look at my table, and there's no zeros on there. So I need to find. All right, so if I look at the table, it's going 1, 2, 3, 4. If I go backwards, this next number would be 0, right? So I can get my y-intercept, but I need to find y. If we were adding 6 each time, that meant that we added 6 to get 18. So what plus 6 is 18? Well, that would be 12. So now I know my y-intercept is 0, 12. Okay. Okay, I need a 0 in my a 0 in my y. Well, I'm at 12 right now. So we're adding 6 each time, so we're going to go back a couple of times. If I go, what plus 6 is 12? Well, that'd be 6, so this over here would be -1. And if I go back another time to -2, if I add 6, what plus 6 is 6? 0. So that'll give me my x-intercept. All right. You need to know how to extend your tables out to find your parts, all right? They're not always sitting there all happy and nice in a little package for you. Let's see. Let's look at another one. Okay, let's look at this one. All right, from -8 to -6, they added 2. From -6 to -8, they subtracted 2. Then again, subtract 2. And then again, subtract 2. So we went from adding 2 right here to subtracting 2. All right, so that means my number was constant, but my signs changed from plus to minus. When it does that, your number's constant, but your sign changes, then it's absolute value, okay? Quadratic, your number's not constant. You change from plus to minus, but your numbers are not constant, okay? Absolute value it is. Because really what it is 2 lines graphed to form a V, okay? All right, so we've got this point right here is where it does its turn. So this is going to be our vertex, which is our minimum maximum. But we don't know if it's minimum or maximum. We don't know if it's facing up or facing down V. So we're going to sketch a little graph just to see. So let's see, 3, -6 would be about here. 4, -8 would be about here. And then 2, -8 would be about here. So we're going to have a downward V. Okay, what I did, I just graphed my turn and then the one on each side. And that tells me which direction, if it's going up or down. So it's going down, so that means I'm not going to have a minimum, but I'm going to have a maximum, and it's going to be at this point where the turn is. So my maximum is at 3, -6. All right, x-intercept, am I going to have one? Is it crossing the x-axis, or will it ever? No. All right, so in this case, you're never going to have an x-intercept. Y-intercept is going to have one. So we know that on a y-intercept, your x is 0. All right, I don't have a 0, but I have 2, 3, 4, 5, so I can go backwards and go 1, 0. All right, so using the pattern of the root of the rule for the function, they were adding 2 here, right? So we're adding 2. What plus 2 is -8? That would be -10. Well, I need to go back one more. So what plus 2 is -10? Well, that'd be -12. All right, so my y vertex is -12. And that makes sense. It would be down here. Okay. All right, and I want to look at one more of the tables. This one, you should be able to recognize right off. This one's exponential. It goes from -12 to 1,008. Yeah, that one's in just 4 steps. That's exponential. I don't have any decimals though. Okay, and the decimals is where I can figure out what it's approaching. Okay, I do see that I have an x-intercept here of 2, 0, but I don't have a y-intercept. I need to find that, so I can go back here, but let's see what we're doing first. Okay, we go from -12 to 0, that's plus 12. Go from 0 to 48, that's plus 48. All right, so we can tell right off it's not going to be in my first difference here. So that's what, 192, and then this would be 768. All right. So I know it's not in my first difference. My ratio, my multiplying is not in my first difference. Okay, but I guarantee you we're multiplying by something to get this. 12 times what is 48? Or I could say 48 divided by 12 is 4. If I say 192 divided by 48 is 4. All right, so that means we're multiplying by 4 each time. Okay? All right, so if I'm going backwards, I'm going to have to first go up here and multiply by 4. What times 4? Okay, what times 4 is negative 12? Okay, so I'm sorry, this is plus 12. What times 4 is 12? That would be 3. Okay, so this would be negative 12 plus 3. All right, so what plus 3 is negative 12? It'd be negative 15. Negative 15 plus 3 is negative 12, so that's going to be our y-intercept. All right, I'm still not in the decimals, and I have to have it in the decimals to see my approaching. All right, so I'm going to go back here again, and we're going to times 4. All right, so what times 4 is 3? Well, I can do 3 divided by 4, and that'll give me 0.75. And just to verify, 0.75 times 4 is 3. Okay. When you're going backwards, you can do the opposite operation. So instead of 3 times 4, it'd be 3 divided by 4. It's 0.75. All right, so then you take this. What plus 0.75 is negative 15. Okay, so that would be negative 15.75. All right, and then this over here will be negative 1. So negative 15.75 plus 0.75 is negative 15. So here's my decimal. All right, this is the first decimal. This is an integer. So you're gonna be approaching and let's look and see how this graph's gonna look, because when I tell you how it's approaching, you're gonna ask a question, I know. All right, so let's graph it. 20 would be here. 348 would be way up here, and way up here, and 1 negative 12 is down here. All right, so it's going to be going a minimum. All right, so we're going backwards. All right, so when you're looking at what it's approaching, you always take the number in front of your decimal. And you say, well, that's because it's a negative, it looks like you're going forward, but don't worry about it. It's always the number in front of your decimal. All right, so it's a minimum approaching negative 15. All right, and then maximum is none. All right, so for the exponential, always take on your first decimal, the first one before it moves to an integer, or no decimal. All right, take the number in the number in front of a decimal. All right, the word problems. Oh, let me do a couple of these just as reminders. Oh, one thing I do need to tell you, this one and this one, these are quadratics, but they're in standard form. You don't know how to do that yet. and it won't be on the test. You're gonna learn how to do that, after Christmas. All right, I do want to remind you though on absolute value. If it's positive, if the leading coefficient is positive, that means we're going a V upward, right? And you take the opposite of the number inside by the X is going to be your X coordinate, and then the number out here is going to be your Y. All right, so take the opposite of this for your X, and then this is your Y. Okay, a quadratic in vertex form does the same way. Okay, for exponential, if it's negative, then you're going to have a maximum. Okay, and it's always going to be approaching that number outside. Okay, if there's not a number, it's approaching 0. All right, so like this one, it's positive, so that means you're going to have a minimum, and it's going to be approaching -5. All right, let's look at some real world. All right, you earn money mowing lawns over the summer, making $20 per week more than what you spend. So you have money in your wallet goes up. After 4 weeks, you start spending $20 more than what you make. So your wallet starts emptying out. The graph below illustrates this situation. Okay? All right, so it says first label each axis. Okay, so I always say that X is your independent, right? So it's usually dealing with time. So we're going to say that this is your number of weeks. All right, and this on the side is going to be the money in your wallet. Okay, because remember he started out putting $20 in his wallet that he didn't spend, and then after 4 weeks he started spending $20 from his wallet. He wasn't adding that $20. That's why it went back to here, but he spent $20. Okay. All right, it says identify the X and Y intercept and describe what it means. All right, so here we have your Y-intercept is at 0, 60. All right, so that means week 0, so at the beginning, he had $60 in his wallet. I know my handwriting's terrible. All right, so at the beginning, he started off with $60 in his wallet. My X-intercept is at 11, 0. So that says at week 11, he has 0 money in his wallet. Identify the maximum and minimum for this situation. Now this situation, yes, it has a maximum here. He can't go below time, right? So this is an end point, so it does have a minimum. Okay, it's kind of like you've got a solid circle here. All right, so the maximum was at 4 weeks. At 4 weeks, he has how much money? Go across here, $140. All right, at 11 weeks, he has $0. He spent everything. Okay. All right, over to your last page there. Let's look at These little. All right, during lunch, you have a competition with your friends to see how high you can flick a paper football. Do y'all even know what that means? I haven't seen anybody do that in quite a while. You fold up a piece of paper into a little shape, a little triangle, and that's your football. And then you hold it on the table between your thumb and your index finger, and then you flick it with the other hand, and it goes up in the air. So we were always, somebody be at the other end of the table holding their fingers up like goalposts, and you try to kick it through there. All right. So, yeah. In case you didn't know that, Joy, we didn't have devices, so we had to make up toys with paper. All right. This is the function gives you the height in feet of the paper football at any time in seconds. All right. So find both intercepts and explain what each of them mean within the context of the situation. All right, so we have the intercept here of your y-intercept is 0, 4. All right, so that means that he started, or he flicked the ball at 4 feet. So he wasn't on the ground flicking the football. He was probably sitting at the lunch table and flicked it from the lunch table. So he's 4 feet up, okay? And then your x-intercept was 8, 0. So that means in 8 seconds, it was at 0 feet. So it was on the ground. So he flicked the ball from 4 feet, it went up and landed on the ground in 8 seconds. Okay. Find the maximum and minimum and explain what it means. Okay, the maximum, so it's a little bit above 6 feet and in 4 seconds. So at 4 seconds, the football was at, or was, let's say, a little over 6 feet in the air. Okay. In 8 seconds, the football was on the ground. Okay. So you've been able to identify your x and y intercepts, your maximum and minimums by looking at a graph. So now you just need to explain what it means in real world, all right? Okay. Sonia owes her mom $210. A payment plan is set up where she pays her mom $15 each week. Wow, she set up a payment plan, really. The equation, she got an equation for her payment plan. Man, mom is serious. Y equals 210 minus 15x. It represents the amount of money, Y, that Sonia still has to pay back. All right, so Y is the money that she owes. Okay, and it says on any given day, X. All right, they've got X up here. Is X day? I think they made an arrow here because it's $15 a week. She's not paying $15 a day. So this should say at any given week. All right, because you would plug in the week for X, not the day. All right, so this down here is going to be week. Okay. Label each axis, we did. The dollar amount owed and the week. It says find both the intercepts and explain in real world. All right, so at 0 weeks, so at the beginning, she owes, and it's a little over 200, and in fact our word problem tells us $210. And then at week, down here we're at week 14. At week 14, she owes $0 to mom. Okay, so she's paid it off. All right, so week 14, she paid it off. Yay. All right. Your work for today, you've got, it's just one page, front and back. On the front, you've got the graphs and the tables, and you need to identify intercepts and minimum or maximum. And then on the back, you've got a few equations to identify the minimum, maximum, and then you've got 2 real-world problems. All right? Do that, take a picture, attach it to your Google Classroom, and y'all have a good day.